Hello everyone, and welcome to our AWS Cloud Implementation presentation for NexaShop Incorporated. My name is Irusha Kasturi Gidar, and I'm joined by my group members Noel Matthew, Moaz Syed, and Mohammed Murtaza. Today we're excited to walk you through our complete cloud infrastructure designed and deployed on AWS as part of our final assignment. NexaShop Incorporated is an online retailer specializing in consumer electronics and smart home devices. Operating entirely online without physical store locations, our business depends heavily on high availability, low latency, robust data protection, and seamless scalability to handle varying customer traffic peaks. Moving to the AWS cloud allows us to achieve high availability across multiple availability zones, auto-scale dynamic workloads, and pay only for the compute and storage resources we consume. Now, let's dive into our AWS implementation.
Hi, I'm Moaz and I handle Task 1 and Task 5. Starting with Task 1, which was IAM, Identity and Access Management, we ensured all roles and permissions were centrally managed by attaching the predefined lab role via the lab instance profile directly to our compute resources.
I took ownership for Task 2 and 3. For Task 2, I constructed our virtual private cloud, NexaShop VPC, spanning two availability zones in the US East 1 region. It includes private and public subnets, an internet gateway for public access, a NAT gateway for private subnet outbound traffic, and custom route tables. I also created the NexaShop Web 5G security group, opening port 80 for HTTP web traffic and port 22 for SSH developer access. Inside a public subnet, I launched our primary web server EC2 instance named NexaShop Web Server. Moving on to task 3, web feature deployment. I SSH'd into the instance, installed Apache HTTP server, and deployed a customized Stormfront HTML web feature for NexaShop, displaying our product catalog. We verified its full functionality by accessing the instance's public IP address in the browser.
Hi, I'm Noel Matthew and I handle both Task 4 and Task 7. For Task 4, our goal was to prepare the infrastructure for like higher computing demands while protecting the servers. First, I enabled termination protection on the NexaShop web server to guard against accidental deletion or termination. Next, to accommodate increased needs, I stopped the instance and upgraded its type to T2 medium from T2 micro. Then I restarted the instance and it updated. Finally, I navigated to the monitoring tab to review the CPU utilization and the network metrics. And then I took a screenshot, which was required according to the assignment specifications.
And in Task 5, which was for storage expansion and backup, I enhanced our web server storage capabilities. I created a 10 GB GP2 elastic block store volume named NexaShop Extra Storage in availability zone US East 1A to match our web server. I attached this volume to our EC2 instance as /dev/SDF, then SSHing into the server terminal. I initialized the volume with an ext4 file system using MKFS and mounted it to the file path /mnt/data for persistent asset storage. To establish data redundancy and disaster recovery, I took a point-in-time EBS snapshot named NexaShop Storage Backup, enabling rapid restoration whenever required.
Hello, I'm Mohammed Murtaza and I manage Task 6 and Task 8. For Task 6, I integrated a managed relational database to store user and application data securely. I created a DB subnet group called NexaShop DB subnet group across our private subnets in two AZs to keep the database isolated from direct internet access. I then set up a dedicated security group called NexaShop DBSD, allowing MySQL traffic on port 3306 exclusively from our web server's security group called NexaShop WebSG. Next, I launched an Amazon RDS MySQL instance called NexaShop DB using the DB T3 micro instance class. To verify end-to-end integration, I SSH'd into our web server instance, installed the MariaDB MySQL client, and successfully connected to the RDS endpoint over port 3306, confirming live query capability with show databases.
I'm returning to cover task 7. So basically, what I did in task 7 was to ensure high availability and automatic response to increased traffic. I created a custom Amazon machine image called Web Server AMI. Uh, and then I set up a target group called Web Target Group and created an application load balancer across our public subnets. I then built a launch template using our custom AMI. Then finally, I configured an auto scaling group linked to the application load balancer and target group. This automatically scales the EC2 capacity up or down based on the traffic it receives and based on the load. So it distributes incoming web traffic evenly.
To conclude, completing this AWS Cloud Computing project has provided our group with invaluable hands-on experience. We learned how AWS services from VPC networking and EC2 commute to RDS databases and autoscaling interlock to form an enterprise-grade cloud ecosystem. Overcoming setup challenges such as configuring database security rules and load balancing reinforced the importance of the AWS shared responsibility model and proper access controls. This project gives us great confidence in building scalable, secure, and cost-efficient cloud solutions in the future. Thank you for watching our presentation.